welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the properties and trends across a period, and specifically, we're going to be looking at bonds across a period. And the bonds we are going to be discussing for today are going to be the oxides of period 3 elements. So, we're going to go to the details of these oxides and how their melting point and boiling point is affected by the type of bonds existing. So the type of bonds across a period, so the number of valence electrons usually play a very important role in determining the chemical bonding. So across a period in the periodic table, the nature of bonds varies from metallic to covalent. And I want you to put in mind what we discussed on the topic where we are looking at the specific bonds for specific elements in period 3. You notice there will be a big difference. You need to separate between the elements that have not reacted with the oxygen and chlorine. The bonds will be different. If you look at the bonds of sodium, magnesium, and aluminium metal, will be different from the bonds of magnesium oxide, sodium oxide, and aluminium. It's going to be different. So see some of those differences, see the similarities, and so that the confusion might not be there. So the structure also varies from giant metallic to simple molecular. So similar compounds in element 3 will exhibit variation in bond types, structures, and properties, just like I've said. So when you look at the oxides now, when you concentrate at the oxides of magnesium and aluminium and sodium, they usually form ionic structures and they have very high melting point. Before we say they are forming ionic structure because you can see sodium, magnesium, and aluminium are metals and they're reacting with non-metal, which is the oxygen. So definitely the bond that is going to be between these two atoms or elements is going to be ionic bond. So it forms a structure which is referred to as ionic structure. This is different from sodium, magnesium, aluminium metallic bond. Now they have reacted. So sodium oxide is soluble in water while magnesium oxide is slightly soluble. When this oxide dissolve in water, they form basic oxides. Sodium oxide reacts explosively with dilute mineral acids, while magnesium oxide reacts at a reasonable rate to form salt and water only. Aluminium oxide is insoluble. Remember, we talked about this. However, it reacts with acids explosively and dilute acids to form salt, but only in special conditions at high temperatures. So this oxide is said to be amphoteric. So we are going to get more amphoteric oxides in form 4, but this is one of the amphoteric oxides because it reacts with both acids and bases. We're not going to go into detail on those reactions because it's a bit on a higher side. We're going to do them more when you get to qualitative analysis in form 4. So we usually refer to it as amphoteric. So we said sodium oxide is basic, magnesium oxide is basic. Both of them can react with acids. Aluminium oxide is amphoteric in nature, although it's ionic. Silicon 4 oxide is a giant atomic structure. We mentioned this when we were discussing on the giant atomic structure topic. While phosphorus 5, 4 oxide and sulfur 4 oxide, phosphorus 5, you also have phosphorus 4. This is phosphorus 5 oxide, sulfur 4 oxide, chlorine 6 oxide, and this is chlorine 7 oxide are molecular in nature. They're molecular. Why? Because you can see they are nonmetals reacting, bonding with other nonmetals. We said when that happens, they bond with covalent bonds between the atoms and weak van Waals forces between the molecule. Apart from silicon 4 oxide. Silicon 4 oxide is the one that is different. But for phosphorus, sulfur, and chlorine, they are molecular in nature. The oxides of phosphorus and sulfur usually react to form acids. We have the phosphoric 5 acid and sulfurous acid respectively. Therefore, they are usually acidic oxides. You see now the difference between the ones that we have just discussed before. Silicon 4 oxide does not react with water or acid, but it reacts with concentrated alkalis to form salt and water only. We are still going to discuss about silicon 4 oxide, especially when we go to extraction of metals, is one of the compounds that forms impurities in most metals. When you extract them, it's usually part of the metal. So it is usually referred to as an acidic oxide. So look at how we have seen sodium oxide basic, magnesium oxide basic, aluminium oxide amphoteric, silicon 4 oxide acidic, phosphorus 5 oxide acidic, sulfur 4 oxide acidic, and then you look at chlorine 7 oxide. Oxides of silicon, phosphorus, and chlorine have no effect on us. They are already acidic in nature, so they cannot further go on react with acids. So this is the overview of the reaction. So we have the sodium oxide, magnesium oxide, and their both are directly affecting the melting point. I hope you can see that. So when you look at sodium oxide and magnesium oxide, you see how their melting point is high and it is increasing across. And then when we get to silicon, which is giant atomic, and you can see how now it's decreasing from phosphorus to chlorine because these ones are molecular. So it is good that you're able to understand the specifics of each oxide. So next we are going to look at a few questions. So the following table gives the melting points of oxides of elements in period 3. Study it and answer the questions that follow. So these are the oxides of period 3. So you can see we have sodium oxide, magnesium oxide, aluminium oxide, silicon 4 oxide, phosphorus 5 oxide, and sulfur 4 oxide. And you can see the melting point. How you can see how like it's increasing and then decreasing. Explain the difference in the melting point of magnesium oxide and phosphorus 5 oxide. So the melting point you can see is magnesium oxide has a higher melting point than phosphorus 4 oxide. The reason why that is so is because magnesium oxide is bonded by strong ionic bonds in its ionic structure, while phosphorus 5 oxide is bonded by weak van der Waals forces in its molecular structure. That's the reason. And then name the compound in the above table that will dissolve both in dilute hydrochloric acid and dilute sodium hydroxide. That means you're being told to identify a compound that is amphoteric in nature. And we said the one that is amphoteric in nature is aluminium oxide. So the answer will be aluminium oxide. Next, below is a table of oxides of period 3 elements. Give the systematic name of that. So this we call it dichloride monoxide. So you see we have 2 chlorine atoms and 1 oxide ion atom. Explain why sodium oxide exists as a solid while sulfur oxide is a gas. So it comes back to the bonds as well. So sodium oxide is bonded by strong ionic bonds in its ionic giant ionic structure, while sulfur 4 is bonded by weak van der Waals forces in its molecular structure. So the ionic bonds are stronger than the weak van der Waals forces. Finally, the table below shows the elements in the third period, the oxides of the third period and their properties. The letters are not the actual symbols of the element. Study the information and answer the questions that follow. So we have that. Complete the table above. So let's complete the table. Sodium is atomic number. N is atomic number 12 after sodium. 14, this is going to be 15. So sodium oxide or M oxide. So this is going to be P2O3 because it's from aluminium. And then this is 15. So it has 5 valence electrons. So it's going to be 2O5. So these are solids, and then also this is a solid. Remember, silicon 4 oxide is a solid, and then for sulfur 4 oxide, number 16 is going to be gas. That's it. Explain the trend in the atomic radius across the period. We said it decreases because there is an increase in the number of protons. Which increases the effective nuclear charge. So the outermost electrons are attracted closely to the nucleus across the period. Finally, explain why the oxides of V does not exist. Remember, V has 18 atomic electrons, so it's completely full on the outermost shell. So we say it has a stable configuration. So it does not react. And when I say react, it means it does not lose or gain electrons. So that ends the lesson. So see you in the next lesson as we discuss chlorides of period 3 elements. See you there.